final speaker for the session, and we're back.
Hi everyone, my name is Emily Black, and I'm a new faculty at Barnard College, Columbia University, and today I'm going to be talking to you guys about my work with my collaborators on operationalizing a pipeline-aware approach to fairness. Let's see, this mic is going to stick with us, but hopefully it will. So as we've been talking about, and many of you guys may know, there's been a lot of legal pressure and enthusiasm recently in trying to prevent algorithmic harm coming from deployed systems. So the big executive order came out recently on Monday, and I think something that maybe I'm thinking about, we're all thinking about, is that are the current methods up to task? And hopefully the answer is yes, but my paper is going to try to add something to some of that. So in this question, I'm going to talk about some of the most common approaches in the machine learning fairness literature, and then talk about how what I'm talking about by pipeline-aware fairness kind of differs from that. So many of us have probably seen fairness papers that kind of put a constraint on top of a pre-made system. You have prediction system. This is thinking about the machine learning world. You have inputs, outcomes, and you're putting some constraints on top of the system in order to satisfy that outcome of equalizing error selection rates. And this is great. It leads to transportable ways to improve equity in a variety of systems across contexts. But there are some downsides of this approach sometimes. One is that you have the potential to increase unfairness by masking true issues. There have been some papers that have come out recently that when you have noisy data, enforcing fairness constraints over that noisy data can actually decrease the fairness of the same metrics. There's also, it can lead to unnecessary performance trade-offs. I had a paper in about 2022 about IRS tax audit models where we show that enforcing fairness constraints over tax audit models instead of fixing some lower level problems can lead to extra performance trade-offs. And finally, there are legal complications. So a lot of the time, these methods kind of boil down to imposing different thresholds based on protected class, and this is actually illegal in a lot of contexts like employment, housing, etc. So what do we do when maybe these top-down approaches aren't enough, or we want to try something else? Well, what a pipeline-aware approach kind of tries to pay attention to is that there's a lot more going on under the hood in a prediction system, and there's lots of decisions that we make when we're creating machine learning algorithms in these contexts. From what the prediction target should be, how are we pre-processing our data, how are we integrating that model into a larger prediction system. And while we most often, as I'll talk about in this paper, intervene on the optimization procedure or the prediction process, ostensibly all of these different choices that we make throughout the machine learning pipeline can actually be sources of intervention to create more fair models. So given that there's so many decisions to make, the pipeline approach kind of takes is trying to leverage the entire AI pipeline to mitigate unfair behavior. And so at a high level, this approach works as follows. Given a model with an undesirable fairness behavior, a machine learning team that's working on this model should search for ways in which the variety of choices made across this machine learning creation pipeline can impact that unfair behavior. So for example, isolating the choice of prediction target, as in the Overmeyer paper that Andrew just mentioned about predicting health need among different populations. That paper showed that it was actually the choice of prediction target, which was associated with the amount of money spent on patients instead of other notions of how sick they were. That led to some of the disparity between Black and white people. So once the cause is identified, you go back through the pipeline, and the team should evaluate whether other choices at that decision point could evade some of this behavior, like changing the prediction target and retraining. And this process should take place iteratively over the creation of the model to create the most equitable model possible. In the interest of time, I won't focus on the details of what I mean by the machine learning pipeline, but hopefully we've seen something along the lines of this figure before, kind of going from viability assessment to deployment and integration, all the steps along the way of making a machine learning model. And something that I do want to emphasize, even though I'm showing this in a linear set of choices, this is an iterative process and cyclic. You go back and forth. And this is also very stylized. Different machine learning pipelines look different in different applications. And the other thing that I want to note is that this pipeline is part of a much bigger system and a much bigger set of decisions. There's biases from the world, there's policies entering into the system, but for the sake of this paper, I'm just focusing on promoting an approach that looks at increasing model fairness at the kind of the actual creation of the machine learning model or algorithm system. And we're not the only people to suggest such an approach. There have actually been papers at EAAMO' before that suggested similar things about a paradigm shift of how we look at making systems with less algorithmic harm. But that's the kind of step that we take is to start operationalizing this approach. So how do we create useful tools and frameworks to actually start thinking about operationalizing this pipeline of our approach to fairness? So one of the first things we do is we show that operationalization is necessary, because if you just tell people about what pipeline fairness is, they're not going to really know how to use it. So we did a classroom study that was IRB approved, where we asked students after a 45-minute lecture on machine learning pipeline and potential sources of harm to think about different use cases of machine learning and to consider where algorithmic harm might come from. Right, they're asked to think about the type of harm observed and potential ways to fix it. And what we found was that this was actually really difficult for them. They couldn't specify how a real world problem got translated into a predictive task. So they said like, oh, it's predicting creditworthiness instead of, risk of default after 90 days. The harms were characterized in broad strokes. They had difficulty mapping harm to a plausible underlying cause. And remedies, and they in general use broad strokes language to describe causes and remedies for harm. For example, saying that the problem of the model was that there was biased data and that it should be retrained with more data, which is maybe true, but it doesn't lead to kind of like a specific actionable way to fix the algorithmic system in question. So given that, it's not maybe potentially clear how to go about using this pipeline of our approach to fairness. What we did as the first step towards operationalization is doing a literature survey along sort of two axes. So the first was what stages of the pipeline, according to that pipeline figure that I had before, like viability assessment, are we thinking about modeling procedures, are we thinking about deployment and integration in this particular work? And then the other axis on which we were looking at the literature is this paper documenting a problem, like for example, documenting the problem about health models and showing that this particular prediction target is not a good proxy and can lead to racial bias. Is this a way to measure biases or to audit systems at a particular point in the pipeline? Or is this an approach to mitigate bias that happens due to decisions at this stage of the pipeline? And so after looking at several papers along these kind of two axes, we were starting to think about what gaps exist in this body of work, in the kind of fair ML work from the perspective of looking at fairness in this way, and what steps can we take to operationalize this approach. So we looked at papers from several conferences over the last 5 years, looking for papers that had to do with fairness and anti-discrimination, equity. So we had around 1,000 papers that we looked at. Of those, 300 met the criteria for kind of being a pipeline-focused paper. This is the result that we got. So the x-axis here is the stage of the pipeline that the paper was about, and the y-axis is the percentage of papers that we looked at that dealt with that part of the pipeline. And then it's also again split up into problem identification, measurement, and mitigation. So as we can see, the focus of the machine learning fairness community has largely been on statistical modeling, with an outsized emphasis on mitigation strategies. And this finding kind of generalizes ideas around the fact that, doing these modeling techniques is really fun. Everyone kind of wants to do the model work and not the data work. So key stages of the pipeline, including viability assessment, problem formulation, and deployment and monitoring, have been understudied, as well as intersections between different stages of the pipeline. Also there's been a particular lack of measurement techniques as opposed to problem identification and mitigation. Now, before I go through kind of our main takeaways from the literature search, I'm going to quickly go through some papers that I just wanted to draw attention to give some examples of how this pipeline and work technique can kind of work. So There's been a lot of work showing that changes in prediction target, which I mentioned slightly earlier, can really impact the equity of the system. So there's this Obermeyer paper that came out about racial bias in algorithms used to manage healthcare, assessing health risk. So if they need extra resources, or the patient needs extra resources for their healthcare, the prediction target was correlated with how much money had been spent on the patient previously. That ended up under-selecting Black patients and over-selecting white patients. I also had a paper that came out in 2022 that showed that if you use classification models to select individuals for audit at the IRS audit, so if you're audited, your taxes have been done correctly, it really over-selects for low-income individuals. But if you switch that to instead predicting not whether or not someone has misreported on their taxes, but how much they've misreported on their taxes, and use that as a basis for choosing who to select, that shifts the distribution towards much more high-income individuals. So that can also impact equity in that situation. There's a really cool paper that was spotlighted at ICLR 2022, which shows that some of the differences in translation accuracy between different languages and NLP models is because of the size of the words that goes into the model. So languages with longer words are going to be less accurate, and it even goes down to the number of bytes per word. So if there are languages that require characters with like tildes on top and dots on everything, since ASCII takes more bytes to store those values, that will also actually lead to increased discrimination. In the interest of time, I won't go over this one, but this basically says that hyperparameter tuning for fairness in particular is also quite helpful, maybe more than we would expect. So all these different stages can impact, all these like interventions that can be thought of can in fact impact equity in employed systems. So after doing this big survey, so reading a lot of papers, we kind of came up with 4 big takeaways. One is that we should document real-world pipelines because they were in the literature, they're often stylized, they look quite different in practice. There are different intervention points in different situations, so it would be good to document them. 2, it would be great to bridge the gap across literatures that have a lot of qualitative evidence about where bias comes from, like in the CHI and CSCW conferences and generally the HCI literature that has lots of rich information about where bias enters in these systems from documentation of examples and sort of the very mitigation focused fair and wrong literature. So these literatures have great things that they're doing, but they're not talking to each other maybe as much as they could be to have a broader understanding of how bias is entering machine learning systems deployed in practice. 3rd, almost all the papers were about a single part of the pipeline and not the interaction effects between different choices. So that's another place to focus on. And finally, there's also holes in the research that we identified, such as not much research around viability assessment and producing measuring techniques. Another thing that we do in this paper in addition to the literature search to start operationalizing this approach to fairness is we create something we call pipeline cards, which draws on a rich tradition from data sheets for data sets and model cards, which is basically a framework for interrogating the machine learning development pipeline in order to search for and mitigate sources of bias. Here are some of the questions from various stages, like viability assessment, testing, and validation, etc. And finally, we created a wiki where we put all of the surveys of our papers. Shout out to Rakshit and Naidu for creating this website. Thank you, Rakshit. We have organized all of our papers into this editable wiki, so you can edit the stages of the pipeline. You can find papers that are examples of different problems or mitigations at different parts of the pipeline. So I encourage you to all check it out. And we hope this can become, as we update it more, a resource for practitioners and researchers to kind of see examples of where maybe they should be looking along the pipeline for different sources of bias and how to mitigate it. But yeah, with that, that's our paper, and that's our wiki. Please join.
Okay, thank you, Emily. I think we've run quite a bit over, but if there's one question, maybe we can take them.
Super interesting work. So one thing that you said is that we seem to be, there's like a lack of measurement papers that are related to these different pieces of the pipeline. So I was previously under the assumption that it sounds like it needs updating, that there's actually kind of like a nice robust suite of fairness metrics that exist for measuring different types of bias and classifiers. But maybe we could speak about that, because I'm sort of changing the idea.
If you're referring to like AIF 360 and all sorts of kind of, so there are, I mean, those are, maybe that's one sort of shortcoming, is that each of those is just one paper out of the 300 that we looked at. But I will say, those are kind of ways of looking at the entire system without a clear indication of what aspect of the pipeline is causing that problem. And so what we mean by measurement here is more like, how can we tell or measure that there's a problem going on in this section of the pipeline? So like, how can I measure that my prediction target was maybe a bad idea? Like, what are some assessments that I can do at that stage to make sure that I'm making a good choice? How can I make sure that my data preprocessing is not causing bias with there's a separate from my mitigation technique. How do I know that the problem is happening in the first place? And that's what I kind of mean by measurement stage.
Makes sense. Very interesting. Thanks.
Thank you so much.
Thank you, Emily. And thank you again for all of the questions. With that, this session is complete. I believe we have a short break for the next session. Thank you.